Okay, we're now going to do an overview of heart anatomy and answer the what questions. What are the layers and functions of the pericardial sac? And what are the chambers, valves, and great vessels of the heart? What are the primary coronary arteries and cardiac veins? Hello, everyone. My name is Dr. Morton, and I'm the noted anatomist. Okay, so the human heart is roughly the size of a fist, and it weighs about 300 grams and beats 60 to 80 times a minute throughout your entire lifetime and pumps 5 to 6 liters of blood throughout your body. It is a very remarkable organ. So the first thing we're going to talk about is the pericardial sac, which is really the packaging of the heart. And the pericardial sac is this double-walled sac that contains the heart and the roots of the great vessels, aorta, pulmonary trunk, and so forth. Now, the parietal pericardium has two layers, a fibrous layer and a serous layer, and the visceral pericardium adheres to the outside of the heart. Okay, so here we have an illustration I did actually in graduate school, and there in green is showing the pericardial sac, which is the sac encasing the heart. And the outside of the heart is known as the fibrous layer of the parietal pericardium. Just like any serous membrane, it's got a parietal layer. But this is made of fibrous connective tissue, dense, irregular, collagenous connective tissue. Now let's take a scalpel and cut the sac open like this. Shing! Now we'll see that the internal surface of the parietal pericardium is the serous layer. That's where it says serous parietal layer of the pericardium. This is what makes serous fluid, whereas the external fibrous layer of the parietal pericardium is dense, irregular, collagenous connective tissue. And then if we now take a look at a cross section, there's the fibrous layer, there's the serous layer. And then the part that's adhered to the heart, that's the visceral pericardium. So let's do this again. Let's take a cross section, however, of the pericardial sac like this and show it. So this is a cross section. Let's get ourselves oriented. There's our lungs that are flanking either side of the heart, and the heart is contained within a pericardial sac, and the outside is the fibrous pericardium shown in green. This is dense irregular CT, and this is what prevents the heart from overfilling. It doesn't stretch a whole lot, so it allows, and it also fixes the heart in the mediastinum. Now, the serous pericardium has two layers, a parietal layer that forms the wall on the inside of the fibrous layer, and then the visceral layer that's adhered to the heart. But notice that if we zoom in, the parietal layer and the visceral layer, they just are continuous with each other. The heart is like a fist pushing in on a balloon this serous pericardium. So, if we now take a look at the parietal pericardium, it consists of two things: the outer fibrous layer and the inner serous layer of the parietal pericardium. And then the part that's adhered to the heart, that's the visceral pericardium. All right, now the pericardial space is between the parietal and visceral pericardial, like that. And this is the fluid. The pericardial space is filled with pericardial fluid, and that's what lubricates the heart. So let's do this one more time in this coronal section, where we take that little bit and blow that up. And what we see is the following. There's the endocardium, which is intimately associated with the blood in the chambers. And then there's the myocardium, or the heart muscle, which pumps blood. And then there's the visceral pericardium that's on the outside, this serous membrane. But if you take this serous membrane, you actually have a lot of adipose tissue. So if you take the visceral pericardium plus the adipose tissue, that's what is formed, the epicardium. But often we just use those terms synonymously. Then outside of the visceral pericardium is the pericardial space that's filled with pericardial fluid. Now, for some reason, this illustration that from my textbook, it looks like that's blood, and that's not blood. The pericardial space is filled with pericardial fluid, which is like water. Then you have the parietal pericardium, the serous layer, and the parietal pericardium, the fibrous layer, and together that just simply is the parietal pericardium. They're like one. Okay, now let's talk about heart chambers. Now, this coronal section, or not coronal, but basically you can see the different chambers of the heart. And there are the chambers and great vessels and valves of the heart. So we're going to talk about them, except instead of using a cadaver, we're going to use a nice basic black and white illustration. So the superior vena cava, or SVC, is the vein that delivers deoxygenated blood from all tissues above the diaphragm to the right atrium. In other words, any veins that are above the diaphragm, blood will eventually from those veins end up in the SVC. Now, the inferior vena cava, or IVC, it delivers deoxygenated blood from all tissues below the diaphragm into the right atrium. In other words, all veins below the diaphragm, all the blood within all the veins below the diaphragm will eventually end up in the IVC. Then there's a structure called the coronary sinus. It delivers deoxygenated blood from the myocardium via the coronary circulation into the right atrium. And so there in blue is the opening of the coronary sinus. It delivers blood into the right atrium. So if we look at this posterior view of the heart, there is the coronary sinus draining over and the blood dumps into that right atrium. There. Okay, so now the right atrium is its function, it's one of these chambers of the heart, is to receive all deoxygenated blood from the body, from the SVC, the IVC, and from the coronary sinus. And if we open up the right atrium, we see a structure on the interatrial septum that contains a structure called the fossa ovalis. And the fossa ovalis is the remnant, the fetal remnant of the foraminal valley, which shunted blood from the right atrium to the left atrium to bypass the lungs in a fetus. The right atrium forms the right border of the heart like this. So there we have the right atrium, and notice that the whole right side of the heart is primarily formed by the right atrium. Now, the floor of the right atrium is this valve, and that's our tricuspid valve, and that's next. The tricuspid valve, I remember this one because it tri to be right, and also tri, RI, is the RI right AV valve. Some ways to remember this. So here's a superior view of the heart with the atria removed, and the yellow arrow shows the 1, 2, 3 cusps that make the tricuspid valve. Another name for the tricuspid valve is the right AV, or right atrioventricular valve. So tricuspid valve, right AV valve, right atrioventricular valve, all synonymous. Thank you, anatomists. Hooray! Now the tricuspid valve opens to let blood flow from the right atrium through that valve into the right ventricle. Then it closes during systole to prevent backflow of blood into the right atrium. Hold that thought. I'm going to come back to it. The right ventricle is the biggest chamber on the right side of the heart, and it pumps deoxygenated blood into the pulmonary trunk, en route to the pulmonary arteries, en route to the lungs to get oxygen. And the right ventricle forms the anterior border of the heart. So if we look at this picture, there's an anterior view, and I've outlined the right ventricle. It's the chamber that forms primarily the front of the heart that touches the rib cage and sternum. So let's now take a little detour from the heart chambers and now talk about heart valves. There's really two types of valves, atrioventricular valves and semilunar valves. We're going to start with the atrioventricular, or AV valves. So here we've got this little blow up. I'm going to take that and show in this little illustration there's the atrium above the AV valve and the ventricle below the AV valve, and then coming out projection from the, and there's the tricuspid valve in this case, okay? Now, the papillary muscles are really extensions of the myocardium, and the papillary muscles are connected to the tricuspid and bicuspid valves via chordae tendineae, or heart strings, dense connective tissue. So in this cadaver picture, there's a ventricle, there's a papillary muscle, that's chordae tendineae attached to the tricuspid valve. So in this illustration, we're going to show the function where the atrium is above the AV valve, the ventricle is below the AV valve, and then there's an AV valve, there's the chordae tendineae, and there's the papillary muscles. And so during diastole, so the function is the AV valves enable blood to flow from the atrium into the ventricle during diastole. Then, during systole, when the ventricles contract, blood is pumped from the ventricle up. And so the AV valves prevent blood from regurgitating back from the ventricle into the atrium by slamming shut like that and making, whenever the valves close, like slamming a door, it makes a sound. We say S1 for first heart sound, the lub in the lub dub. Now, the chordae tendineae ensure that the AV valve leaflets do not prolapse into the atrium. You see that? Now watch what happens. Shing! Do you see that? So what happens then is when the blood forces those AV valves shut and the blood then continues to balloon up, because these valves are connective tissue, and so like parachutes, they'll balloon up, but the chordae tendineae prevent these valves from the leaflets from prolapsing into the atrium. See that? Now, without them, meaning the chordae tendineae, regurgitation occurs. So watch. We take away one of those chordae tendineae, and when the blood pushes up against the valves, then the valve leaflet prolapses and blood can move from ventricle to atrium, causing a lot of problems. Okay, so now the pulmonary valve is the next one we're going to talk about. And so the pulmonary valve in this cross section with the atria removed and a superior view is the most anterior heart valve. And it opens to let blood flow from the right ventricle through the pulmonary valve into the pulmonary trunk and pulmonary arteries and ultimately going to the lungs to get oxygen. And the pulmonary valve closes during diastole and prevents backflow of blood into the right ventricle. So let's talk about semilunar valves now, or their function. And so the ventricle is below and the pulmonary trunk or aorta are above the semilunar valves, and there's a semilunar valve. So watch what happens during systole. The semilunar valves enable blood to flow out of the ventricles, and then during diastole, prevent blood from regurgitating back into the ventricles from here to here. And whenever valves close, like slamming a door, it makes a sound. We say S2 or the second heart sound, or the dub in the lub-dub, lub-dub. Pulmonary arteries transport deoxygenated blood from the right ventricle to the lungs, like that. And so this is something you want to put a little caveat, a little star, a little happy face, a little Canadian flag, because pulmonary arteries are the only arteries in an adult that transports deoxygenated blood. The only one. Fetus is different. We'll talk about that another time. And so the pulmonary arteries, and I always remember arteries for away. So if this is A for away. And so if you forget or get this mixed up, always remember that the arteries take blood away from the heart. And why are we sending blood from the heart, away from the heart to the lungs? Why are we sending it to the lungs? Because we need to get rid of CO2 and we need to get oxygen. And so the blood going away from the heart to the lungs is rich in CO2, and we're going to get oxygen. Pulmonary arteries, right there. All right, so the middle of the top picture shows the heart, and then you got the right and left lung, and then watch pulmonary arteries send through the left and right pulmonary arteries to the left and right lungs to get oxygen. So here we have the trachea and bronchial tree, and we're going to take a look and blow up this little bronchiole and see that oxygen is inhaled through this bronchiole and goes into these things called the alveolar sacs. And alveolar sacs are these terminal air spaces where gas exchange is going to occur because pulmonary arteries are bringing CO2-rich blood to these pulmonary capillaries. And so we're at these pulmonary capillaries. This is where gas exchange occurs, where the pulmonary capillary blood is rich in CO2 and poor in oxygen. Where the alveolar sacs, within their space, it's rich in oxygen and poor in CO2. So we have a high to low concentration. CO2 diffuses into the alveolar space and oxygen diffuses into the pulmonary capillaries. You then exhale CO2 and the blood exiting the pulmonary capillaries and the pulmonary veins is rich in O2. It's now oxygenated blood going back to the left atrium of the heart. So here we have the pulmonary veins bringing oxygen-rich blood back to the left atrium. So pulmonary veins transport oxygenated blood from the lungs to the left atrium, and like those arrows showed, and this is the only vein in an adult that transports oxygenated blood. Put a little happy face or an emoji, like a poo emoji if this bugs you or whatever, to remember pulmonary veins are different than the systemic veins in the blood that they transport in the house that Jack built. And in this posterior view of the heart, we see the left atrium, and then you have two pulmonary veins on the left and two pulmonary veins on the right dumping blood into the left atrium. If you hear like yelling, everything's cool. I just have a teenage son that's above me on the floor and he keeps yelling and playing with their dog Winnie. So I keep trying to record. I'm just going to keep going. So if you hear it, everything's cool at the Morton household. All right. Now the left atrium, there's our left atrium. It receives oxygenated blood from the lungs, as we talked about, shing, like that, and it forms the most posterior border of the heart. And so here we have this posterior view, and there is that left atrium. It's the most posterior, and it's what actually touches the esophagus in the thoracic cavity. Now, the bicuspid valve gets its name because it has 2 cusps, as shown here in the superior view. But it's also called the mitral valve. Why is it called the mitral valve? Because if we take this heart, and you can see this mitral valve, and turn it upside down like this, and we look at this religious hat, it's called a mitre. And the mitre, early anatomists said, hey, that kind of looks like our valve. So they called it the mitre valve or mitral valve. But that wasn't where they ended. They said, well, instead of just the bicuspid valve, because it has 2 cusps, or mitral valve, because it looks like a mitre, why don't we also call it the left AV valve, because it's the atrioventricular valve on the left. And I just remember mitral, L for left. Okay? The bicuspid mitral or left AV valve opens to let blood flow from the left atrium to the left ventricle. And so it closes during systole to prevent backflow of blood into the left atrium. So here we have, watch, shing, shing. It prevents blood from going from the left ventricle back into the left atrium. And when that bicuspid valve shuts, it makes the S1 or first heart sound. Now the left ventricle receives oxygenated blood from the left atrium and pumps it into the aorta, like that, through the aortic valve. And notice the thickness of the myocardium of the left ventricle and the thickness of the myocardium of the right ventricle. Now we take a look at a cross section of the heart. Look at the thickness difference. We're talking about, 10 to 20 millimeters of mercury pressure is what the right ventricle pushes up against to open the pulmonary valve, where you're looking at 80 to 120 millimeters of mercury pressure for the left ventricle to push against to open the aortic valve. Much thicker myocardium as a result. That mean arterial pressure in systemic vessels, arteries, is bigger than pulmonary arteries. Now, the left ventricle forms the left border and apex of the heart. So when we look at this anterior and posterior view of the heart and we outline the left ventricle, that's what forms primarily the left border and the pointy apex of the heart. The aortic valve opens to let blood flow from the left ventricle into the aorta. And so in this cross section, there's our aortic valve, which is behind or posterior to the pulmonary valve. And we have coming off the left cusp, the left coronary artery, and the right cusp, the right coronary artery. And so the aortic valve closes during diastole and prevents backflow of blood into the left ventricle. So here we have the aorta above and the left ventricle below, and watch, shing, shing. During diastole, blood flows and slams those semilunar aortic valves shut. It makes the S2 sound, or the second heart sound, the dub in lub dub. We're now going to talk about the aorta and how the aorta delivers blood to systemic and coronary circulations. And so I'm actually not going to talk too much about it, other than on this cadaver, there's the aorta, this really big artery, and it is the thickest elastic muscular artery. It's considered an elastic artery because it's got so much, like 50% elastic tissue and 50% smooth muscle in the tunica media. Takes a lot of pressure, and that's what distributes blood to all systemic arteries and arterioles. Let's now talk about coronary circulation. So, what is the coronary circulation and why do we need it? Here's this coronal section of the heart. There's oxygen in the left ventricle, and there's myocardium. We would think that oxygen could just diffuse and supply this myocardium, but it doesn't work that way because the blood is moving too fast at too high of pressure. So what is the coronary circulation? It's blood, the heart pumping blood into the heart, and the heart delivering blood back to the heart. Now, what we mean by that is that the left ventricle pumps oxygenated blood into the ascending aorta, which then gives rise immediately to left and right coronary arteries, which then supply the heart, meaning the myocardium, the actual heart muscle tissue. And then the heart muscle tissue gives its deoxygenated blood back to the heart via cardiac veins into the right atrium. So blood goes from the heart, through coronary arteries, to the heart, and through cardiac veins back to the heart. It's a circulation or circulatory system. So the major arteries. First one is the right coronary artery, or RCA. It's what supplies the right side of the heart. And so there, this yellow arrow showing the right coronary artery coursing what's called the coronary sulcus, which courses the right crown of the heart. And so here's a superior view of the heart, and the atria have been removed, and then I'm outlining the aortic valve and then highlighting the right cusp of the aortic valve, and then there's the opening giving rise to the lumen to the right coronary artery. And so the right coronary artery, the word coronary means like a crown. So if you think of someone's head and you put a crown on their head and you go, oh, where the crown moves around the head, that's what's like the coronary artery. It courses in this coronary sulcus like it's a crown. Okay? The right coronary artery supplies the right side of the heart, and it also gives rise to some other branches like the sinoatrial nodal artery, or the SA nodal artery, which supplies the SA node, which is the pacemaker of the heart. And so we now take a look at this posterior view. The posterior descending artery, or PDA, supplies the posterior interventricular septum. And so there's the left ventricle and right ventricle, and the PDA is demonstrated on the posterior view. We see it, and then the anterior view, we see it ghosted as if you're looking through, like Superman looking through the heart. Now, anatomists also call this the posterior interventricular artery because it's on the posterior part of the interventricular septum. Now, the left side of the heart, we're going to talk about the left coronary artery, or LCA. It supplies the left side of the heart. It's actually quite small, and it courses in the coronary sulcus, but that much, like it's really short. And it technically itself doesn't supply anything, but it does supply the heart via its branches. So here's a superior view. There's the aortic valve and the left cusp highlighted, and there's the opening, and that's it. That's the left coronary artery. See that little bit? Like a centimeter long. But it gives rise to two major branches, the LAD and the LCX. Let's talk about those two branches. First, here's our left coronary artery, and the first branch is called the left anterior descending artery, or LAD, there. Left because it's coming off the left coronary artery, anterior because it's on the anterior part of the heart, and descending because it descends on the front of the heart. And it supplies the anterior interventricular septum, because there's the right and left ventricle, and it's coursing in the septum between them, as well as the apex of the heart. And because it's between the two ventricles on that interventricular septum, on the front, we also call it the anterior interventricular artery. But you'll probably know it as the LAD for the rest of your career. Now, the left coronary artery also gives rise to the left circumflex, or LCX, for left circumflex artery, and it supplies the left lateral wall. And so in the superior view, there's that left circumflex. You notice it's coursing in that coronary sulcus, or coronary groove. Now, we've got to get the blood back to the heart, so we do it through venous system, and there's a coronary sinus, and this is what drains all the tissues of the myocardium of the heart. And so there's our coronary sinus, Now, the great cardiac vein drains the same cardiac territory as the LAD. So we look at the anterior part of the heart, and there's the great cardiac vein coursing around and joins in the coronary sinus. Then there's the middle and small cardiac veins. They drain the same territory as the right coronary artery. So there's our middle cardiac vein on the back of the interventricular septum, and there's our small cardiac vein along the right margin of the heart. And so the coronary sinus drains all the heart. So there's the coronary sinus, and so it drains and collects all the venous blood from the great, middle, and small cardiac veins, and then it dumps into the right atrium and brings their blood, deoxygenated blood, to the right atrium like that. So here we have the aorta giving rise to the right coronary artery and the left coronary artery, which branches into the LAD, and also right along the LAD paralleling is the great cardiac vein. And then there's our left circumflex coursing around the back. And then here we have the right coronary artery giving rise to the posterior descending artery, which is at the same area as the middle cardiac vein. And then there's our coronary sinus. Now, I would mention here, which is an interesting thing, is that anatomists for some reason said, we're going to call all the arteries that supply the heart coronary arteries, and all the veins that drain the heart cardiac veins, even though they technically could use them synonymously, but we don't. When we refer to the arteries of the heart, they're coronary arteries. When we refer to the veins of the heart, they're cardiac veins, except for the biggest one we call the coronary sinus, primarily because it's coursing in the back of the coronary groove. Okay, let's now do heart anatomy in a nutshell. So here we have deoxygenated blood in the right atrium, which then flows through the tricuspid valve into the right ventricle, and the right ventricle pumps this deoxygenated blood through the pulmonary valve into the pulmonary arteries, taking blood away from the heart to the lungs. And we go to the pulmonary capillaries in the lungs because we need to exchange CO2 with oxygen. Now, the oxygen-rich blood exits the pulmonary capillaries in the pulmonary veins. This is now oxygenated blood. And this oxygenated blood from the pulmonary veins flows into the left atrium. The pulmonary circulation is blood flowing from the heart to the lungs, back to the heart. Right ventricle, pulmonary capillaries, left atrium. That's pulmonary circulation. Now, the oxygenated blood, oxygenated, flows through the mitral valve into the left ventricle, and the left ventricle pumps this oxygenated blood through the aortic valve into the aorta and systemic arteries. And this oxygenated blood flows to all these millions of tissues and capillaries, and we call these systemic capillaries because they're in the systems of the body, like musculoskeletal system, nervous system, skeletal system, digestive system, and endocrine system, and so forth. So the systemic capillaries, we go there because we need to deliver oxygen to the systemic tissues, and then we also are then receiving the carbon dioxide from these tissues. So the blood exiting systemic capillaries into the stomach veins is deoxygenated blood, and this deoxygenated blood goes back to the heart. So the systemic circulation is the blood pumping from the heart to systemic tissues back to the heart. That's what's meant by systemic circulation. And we go back to the right atrium, back to the very beginning. A very good place to start. Good movie. If you have not seen it, very good movie. Okay? And that, my friends, is heart anatomy in a nutshell.